this next part here, we're looking at how do we use position and work out angles and vice versa. So here you've been given a point, -4, +9, somewhere right about there. Okay, so -4 along the x, +9 along the y. And it locates that point. It also has a standard position angle associated with it. Okay, so that angle is our angle theta. That locates that point. That point can be described in the same point can be described with coordinates, -4, +9. So we want to find out the trig ratios. Well, I need to know all three sides of that triangle to work out the trig ratio. So if I do 9 squared plus 4 squared, that's going to get me 97. So square root 97. Now what's implied is when we start doing these problems is we need to keep these exact values. So once we have that triangle with exact values, I can write my primary trig ratios. Sine theta is going to be my y. My sine is vertical, okay, over root 97. Cosine is horizontal, or x. Negative, that's really important. That negative is important because that differentiates this position, this angle, from the angle in quadrant 1, which would be +4. And again, position is very important. That's why it's called standard position trig. The tangent is slope. The slope of that line is negative. It's going to be 9 over -4, or -9 over 4. Okay, that's my slope. The last part of this is I want to know the angle. Well, the angle, I need to be able to translate from ratios to angles or position to angles. I need my calculator because I don't really know what the translation is. So my calculator is kind of like my translator. So I'm going to use, let's use tan. So I'm going to go second tan, -9 divided by 4. Now I get oops, my mode's wrong, so I got to change back to degrees. So if I do that again, I get -66.3, okay, 0.3. So I'm going to write like this. Arctan of -9 over 4 equals theta. And I'm going to call that theta 1, and I get -66.03. Now this is a big problem here. And this is in different color because that's a big problem, because -66 degrees is not where that picture is showing me where that angle is. -66.03 degrees is my theta 1. That's definitely not negative, that's positive. And that's not 66 degrees. -66 degrees is somewhere around here, right about there. Okay. Now, what do you notice about the symmetry of the green point and the blue point? Well, they're symmetrical. They are related. In fact, and there's nothing wrong with this, my calculator, because that point there gives me the same negative slope. Okay, and that's what tan is. Okay, I wanted the angle that gives me the slope of -9 over 4. Yeah, I got the right point. Wrong spot. Now, what you need to understand is that there's always going to be two possibilities. Your calculator is going to give you one, but it may be the other. You always have to consider two positions for this. When the coordinate is defined, there's not two possibilities. Okay, we can narrow it down. We can eliminate one of these two possibilities as a possible answer. Now, it's got to be the other one. How do I find the other position? Well, due to symmetry, I know that if I start at -66.3 degrees, 0.3, I just have to go to the other side of the circle, or add 180, and I get 113.97 degrees. Yeah, that's the right position. Okay, so there's always two angles to be considered. Your calculator will give you one. It's not always the right one, and you have to use the symmetry to get to the right position. So in this case, I use tan, and tan has this symmetry. Tan is slope. So I can find the other position using slope, and that's on the other side of the circle. Okay, So that issue we're going to visit again and again. So let's take a look at a different problem. What's exact? So exact means exact values, so we're probably talking special angles. What's the point exact coordinates on the circle of radius 6 that defines negative 240 degrees? Sorry, 240 degrees. So 240 degrees is going to be right about here. It's in quadrant 3. Okay, and it gives us this triangle. Since that's 180, we know that this is a 30-60 triangle. Now, I need to locate that coordinate. Where is that point? Well, if I know my standard position circle, if I know my special angle triangle, I know it's going to be 1, 2, square root 3. Now, this is the same triangle, except this one is 3 times bigger. So if I want to then work out the location, so the position, the horizontal position and the vertical position, well, I could use these two numbers here. But it's going to be 3 times bigger. So I'm going to end up having a length of 3 here and a length of 3 times square root 3 here. Now it's really important that we remember its position. This is not 3 to the right, it's 3 to the left. So I have to give it a position of negative 3. This is negative 3 root 3. So my position then, remember that x and y represent position, and right and left are different. We have to distinguish right and left. The position that we want then is going to be located by negative 3 root 3.